All right, we're going to look at part two, or this is part two for the video for the answer key for the review guide for chapter one. If we take a look at number 7, what is the difference between a chemical and physical property? Well, chemical properties can only be observed during a chemical reaction. So if I wanted to know if something were flammable, I would have to light it on fire. And if you're lighting it on fire, you're going to have to do some changes to it. So the stuff that goes into the flame is different than the stuff that comes out of the flame. So we've got a log, comes out as ashes, carbon dioxide, water vapor, no longer a log. Whereas a physical property, by measuring a physical property, you're not having any effect on the substance itself. So if I measure something's length, I'm not changing what it's made of when I'm measuring that. So that's the difference between a chemical and a physical property. If we take a look at number 8, if we want to know the difference, or if we want to be able to convert between Celsius and Fahrenheit, in this case we're going to have to use the formula temperature in Celsius is equal to our temperature in Fahrenheit minus 32 all over 1.8. And if we do this, if we do the math, we plug in the numbers, 105 minus 32 all over 1.8. This should give us 40.6 degrees Celsius. For Kelvin, our temperature Celsius is equal to my temperature in Kelvin minus 273. And if we plug in 386 Kelvin, I forgot the 6 there, minus 273, this should give us 113 degrees Celsius. We're going to put this number into scientific notation. I don't like that decimal point is there because that's going to make all of these trailing zeros significant, which means we're not going to really save any space by putting this into scientific notation. So let's just, for the sake of this problem, I think I have it different on my answer key. Let's just use it as this number here. So the coefficient I'm going to put out in front is going to be 7.89, and then we're going to do times 10 to the, we're going to figure out how many places we have to move this decimal place. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 10 to the 9th. So 7.89 times 10 to the 9th. When I put my answer key up, I noticed that I answered this question with the number 10 and not the answer from number 10. So on the answer sheet, I said how many significant figures does number 10 have? Well, the actual number 10, as in the number that comes after 9 and before 11, has one significant figure. We've got a trailing zero, no decimal place. So I think on my answer key I have 1. But really what I should have been referring to is the number of significant figures in problem number 10. In that case, just count the number of non-zero digits or significant figures in the coefficient for my scientific notation. And it looks like there's 3 of them there. So I would, if you did this on a test, I would have to give you credit because I wasn't clear here. But I should have said problem number 10. But this is what I'm looking for, number 3. And if we take a look at number 12 here, we're going to take 0.0400 times 39.85, and then we're going to divide that quantity by 1708. So if we do this, we're going to end up with 9.33 times 10 to the negative 4th. We've got 4 sig figs in each of these things. Actually, this will bring it down to one more 3 there if you look at the number that pops out in your calculator. So we've got 4 sig figs here. If we take a look at number 13, we're just going to do a metric conversion. Anytime I've got a metric conversion where it's something that's not in the base unit, I always like to take it to the base unit and then take it to what I'm looking for. So we're going to do 964 millimeters. We want to convert this to meters, and there are 1,000 millimeters in 1 meter. And then we want to change meters now into nanometers, and a nanometer is 1 billionth of a meter. So that's going to be 1 times 10 to the 9th meters, nanometers. So if I throw the calculations in here, it should give me 9.64 times 10 to the 8th nanometers for my answer. Stay tuned for part 3.